Hi everyone, I'm very excited to be here on droidCon online event. I always enjoy droidCons offline and online, but this year we attend rather online conferences, so that's the situation. But let me introduce myself at first. Most of the time I work on Android applications with Tango Digital Agency in Kraków, in Poland. And besides that, I do some freelancing projects that are worth extra time. I write blog dedicated to testing with Kotlin and Kotlin testing related tools. My sport activities are focused on volleyball, both indoor and beach volleyball, and I also create music. If you are interested, you can hear my work, my beats on Spotify and other popular streaming services. Link to that stuff is aggregated in the link you can see on the screen on Social Hub, available also on the QR code. But let's not forget why we're here. We are here to talk about the fundamental concept of unit testing, test doubles. I will share my thoughts about unit test and especially using test doubles for better and more efficient mocking. Here you can see the test pyramid, which is some kind of graphical representation of how test suite should be designed in process of software development. On the top, we have end-to-end tests. In Android case, that would be automatic UI test using frameworks such as Espresso or Appium, stuff like that. The second stage are integrations tests. In this case, we could be testing integration between elements, basically integration between high-level components. In Android, we could use libraries such as Roboelectric to mimic some system behavior or even trigger some actions on views. And on the bottom of the test pyramid, we have unit tests. Tests that are performed in isolation, are relatively cheap, and should be running fast. And usually, in software projects, there should be much more unit tests than any other kinds of automated verifications. And unit tests and ways of keeping isolation is the main focus in today's presentation. Let's take a look at this puzzle. They represent some kind of software system where each puzzle is some component. As you can see, they are somehow connected. While we are focusing on the class we want to test, we should take care of its direct dependencies, marked in yellow. And in unit tests, we don't care about other components that are not strictly bound to the system under test. So let's break it down a little. We have our class, a system under test, and some components that are its dependencies, usually passed in constructor. We won't pass the whole dependency, but try to somehow provide a test double object which will fit right into particular puzzle in a convenient way. And I have Android background, and I believe most of us are Android developers. So let's try to present test doubles in Android context. In Android apps, we usually have some kind of splash screen displayed right after app is opened. In this place, we should decide if user should be redirected to the main screen of the app or show him login screen. And splash screen dependencies are hidden behind an interface. We have router, which is responsible for opening given screens. We have interface for view, such as activity fragment or custom view, where we would display error or trigger loading indicator. We have also use case which will tell us if user is actually logged or logged out into our app. And last, we have some property for analytics. This could be for example, string representing some advertising campaign from Google Play or other stores, stuff like that. So what should we test here? What should be tested? Of course, stuff like displaying loading indicator. If our presenter is triggering a router to go to proper places. And finally, verification if error is displayed when something in the logic of the presenter goes wrong. So let's see how it fits into our puzzle and decide how we should create test doubles to have Splash presenter isolated. Let's take care about first dependency of Splash screen presenter, Splash router. A real implementation would start activity, change something on fragment manager, or trigger something in the navigation graph with navigation component. And in the test double, we want to know if a given function was invoked, so we could perform assertion on that. And another dependency, view. Android implementation would be directly bound to the layout in XML. It would be changing visibility of some loading indicator or trigger snack bar event, for example. And in our unit test, we cannot mock the whole activity on fragment, so we need to provide test double, some kind of object that will record its interactions or somehow store the whole state of the screen. Okay, next dependency, use case. This class would check user existence in local database or simply check token validity, then reduce that information to enum class indicating if user is logged in or logged out. And in our fake implementation, we will just return given enum values or throw exception to simulate real system behavior. And finally, tracking ID. In real application, that string would be passed from external application or external component. And in unit test, we can directly provide fake value. So now we are ready to distinguish some kind of test doubles. We have stub, which will be used to return predefined value. We have fake, where we would create some lightweight implementation for our dependency. We have mock, where we would be storing information about its interactions. And we have dummy value, some property we pass to unit test just to satisfy compiler, but we won't take care of it. And it's good to remember that we often call all test doubles mocks. So now let's see how we can create mocks for each dependency in our Splash presenter. Let's start with resolve user state use case. It is interfaced with one method, so we can return values directly. It is also a Kotlin functional interface, so this could be done in this single line in Lambda. And we could return state logged in, state logged out, or just throw exception from that method. Next thing, similar to stub could be dummy value, but the difference is dummy value is not used in that particular test case. We often don't use it. We pass it just to have build passing. We have mock. We want to somehow record interactions with Splash router. And we can use here mocking framework, such as Mockito, to verify if given method was invoked. And we can use stuff like Mockito to perform assertion. We create router with Mockito and then verify with Mockito function, verify if this method was called. And of course, there is opposite case. When user is logged out, we expect to open login screen instead of the main screen. And we can also provide Mockito mock for view. In case of exception thrown by resolve user state use case, we want to display error on view. And thanks to Mockito, we can perform this verification in single line too. Yeah, that use case throws error. And then with Mockito, we verify that display error method was invoked on a view created with Mockito. But it's good to remember that we are not bound to mocking frameworks. We can provide our own lightweight implementation by ourselves. And a good example would be the view of that splash screen. Somewhere in the test directory, we create an implementation for that view interface, which will keep the state of loading indicator and record information that error was displayed. So in that case, when in our test we throw exception and display error was properly invoked on view, we can simply check if our fake state was changed. And instead of using Mockito for verification, we perform simple assertion on property in our fake object. So effectively, what are the differences between mock using framework and custom fake? Mock can be created for us by frameworks such as Mockito, Mock-K, and for more complex cases, of course, we can configure this mock to create more complex objects. And we can, of course, use matchers. I will show the example later to verify how many times given function was invoked and with which arguments. Fake, in the other hand, has to be implemented by you, by the developer. In non-complex cases, such as a splash screen, as shown before, it's just implementing interface and adding some Boolean properties to this fake. And you are in full control in here. You can decide how this fake should behave, and effectively you can reduce complex verification to simple assertions, as shown before an example. One of the most popular mocking frameworks for JVM is Mockito. It allows creating mocks in a simple way, even in one line. And I will present usage of Mockito with Mockito Kotlin extensions. So let's consider another screen with view model presenter architecture. We have some view which will display list of items. We have data source such as database described by interface with two methods, get all elements and get one element by ID. And we will use Mockito to create stub for data provider and to create mock for view. So let's jump straight into the first test case. We want to verify that if data provider returns non-empty list of elements, then all that items would be displayed on view. So first, we create mock for our view. Then we create mock for data provider with proper stubbing. On getAll method invocation, we will return given list of elements. And then we are starting presenter and using Mockito function verify. So we could check that display items was invoked with that given list of elements. That was pretty straightforward example, so we could do something else. Another test case for that presenter could be verification of displaying only one element. And here we have stub for another method of data provider, get1. With Mockito, we can stub a very specific method invocation. We write that on get1 method with any parameter, it should return given element. Any is here example of matcher. This method would be stubbed for all possible invocations, excluding null values, because we have separate method for that. And then with this configuration, we can proceed to regular verification on view. With Mockito, we verified that display details function was invoked with given element that was returned by mocked data provider. And we can introduce more complex matchers if we need to. Let's suppose that we want to return always the same element for function invocation, where ID, described by integer value, is between 0 and 5. And we could use Mockito matcher arg.dat. In that lambda, we write Boolean expression. And while performing stubbing, Mockito will check that Boolean lambda, and will return given element for elements matching this expression. And for function invocation, where ID is higher than 5, it will throw exception. And matchers can be used for verifications too. In this example, we can use similar matcher in assertion in verification on display details, and make the test pass for every argument that matches given Boolean expression, especially in this test case, for that argument which content is equal to string first. And that's not everything that Mockito can do for us. We can perform other assertions and verifications as well. And now we are testing path where the data provider return null value instead of valid element. And then we want to verify that error was displayed on view and that display details was never invoked with any arguments. We have special functions for that kind of stuff too. And of course, all of those things could be achieved without using Mockito. For every test case, we can provide our own lightweight implementation and create custom fakes. This may be convenient when we are not sure how a specific Mockito matcher should be used in here, or we would really need to stretch the mocks to really mimic behavior in tests, to mimic this behavior we want to achieve. And in general, there is no silver bullet for creating test doubles, and every test case is special in its very own way. And also we should remember that Mockito is Java framework, and especially nowadays in Android world, we use Kotlin. And unfortunately, Kotlin-specific feature, coroutines, are not directly supported by Mockito. When we will try to mock suspend function with Mockito, test code simply won't compile in that way. We could, of course, try to use generic Mockito mechanisms such as doAnswer, construct, but we could lose readability of this domain-specific language. And there is another framework for that we could use. This is mock-k. Mock-k is Kotlin first library with DSL-style stepping mechanism and with built-in coroutine support. With mock-k, we just write co every from coroutines, I guess, and create stepping in a similar way that we would do with Mockito, but coroutines are supported. I believe we will have at this event another talk about mock-k, so you should see that talk if you want details about mock-k. And there is, of course, other solution for mocking suspend functions. We could just create simple fake instead of relying on framework. We can implement that interface if it's convenient for us and implement that given suspend function with our stubbed data. Okay, next thing. Static properties in Java and in JVM libraries are very common. Some developers love to use static constructs, while others are criticizing every aspect of static keyword. That's not for me to tell if static is good or bad. It's a tool, it exists, and I will show you a few approaches to handle static access in test code. But let's check again our puzzles with system under test dependencies. Static objects are not direct dependency of system under test. In a way, they are part of it, as well they are kinda outside. And the most straightforward way to include in a reasonable way static dependency in test is to remove direct static access. If you need to change behavior of some property in test, you could just use extra interface or facade to abstract it away. First example could be using datetime .now method from YodaTime. We have our code relying on YodaTime, and we use it in an abstracted way. We create provider for datetime. We execute in our system under test this wrapper method, and we can easily mock that interface. And other case that developers using RxJava may be familiar with is abstracting away every scheduler we need to use in a system under test and injecting that facade into presenter or view model. That's, I think, the best example of using wrapper to remove static access in test code. And sometimes static methods are invoked underneath, just like it could be in live data. Some kind of approach of live data using Android main thread under the hood could be delegating main thread executor and setting its value before we execute our test suite and releasing it when we're done. This before spec and after spec are callbacks from co-test specifications. Before spec will execute just before we execute our first test case, and after spec when all test cases are run. And of course, for mocking static things, we have library. Mock-K actually allows us to mock static things. For one of my pseudo integration tests for data binding, I used Mock-K to mock Android looper. And that's possible. Should you do that? Probably not, but it's a way you could hack some things. So how can we approach testing static things? If you can remove static keyword and then rewrite particular piece of code, that's great, just do it. And if that's not possible, and you should depend on that static access in your unit test, try to at least create provider or a little abstraction for that. And if this fails, check if you could set something globally. You could globally probably set date time, date zone, stuff like that. And if other things failed, you can use mocking framework to do the hard work for you. You can use Mock-K, PowerMock. PowerMock was popular in Java when I was developing Android apps with Java. And of course, if you are brave enough, you could try to use reflection to modify existing properties in runtime and then use static objects in your test with proper configuration. And sometimes library developers also provide some test extensions for methods that they exposed in a static way, so you probably could use that. Okay, to sum things up, we talked about fundamental concepts of unit testing, test doubles, and in the end, I want to give you a few takeaways. Know your test structure. With given when then flow, you will find creating test doubles much easier. In the given section, prepare dependencies for your system under test, configure stubs. In when section, execute logic you want to test, and in the end, compare your results, your system under test generated to your expected output. Know when to use proper test double. Sometimes you only need to pass stubbed value or simple fake, so there's no need to use Mockito or Mock-K for that. Don't overuse mocking frameworks. Using Mockito just to return predefined value could be overkill for your system, and when you have very big test suite, it could lead to performance issues. And sometimes it's easier and more efficient to write fake yourself. And last but not least, keep good separation of concerns, or at least use constructor injection. It's not impossible to provide fakes for static variables and objects, but readability comes first. If your code is solid and in general follow dependency inversion principle, then you are good to go with writing great test suites that will serve you, your team, and your project very well. So, thank you for your attention. That's all from me today. I hope that you enjoyed my presentations. And for more unit testing related content, you should check my blog, kotlintesting.com. If you want to find me online, go to the link you see on the screen, ping me on Twitter. and I am open to discussion. I think we can start Q&A. Okay, we have an anonymous question. Should we prefer fakes over mocks? If yes, is there a way to use fakes without interfaces? Interfaces that are needed just for testing seem like too much effort to justify it. Example, use cases in presenters view models. Okay, should we prefer fakes over mocks? It depends on your use case, of course, and in general, your programming style. Probably you don't want to use Mockito for everything, and also keeping a custom fake with for single method for interface or class with single method could be more efficient in that way. It actually lets you write production code in more solid way. Good tests will suit very well code that follow dependency inversion principle and other principles defined in solid. So should you use interface for every little use case? Probably yes. I think Uncle Bob would say yes, but in a real situation, it depends on a specific use case. Every test case is specific and very special in its very own way. Have you do some runtime benchmark between using fake and mock? No, I didn't. What strategy should be used for private methods? Well, first of all, you shouldn't be using private methods. You shouldn't be, of course, you should be using private method. You shouldn't be testing directly private method. You should be testing private method interactions between your components. You don't want to test if some internal state changed in your system under test. You should rather test output and input of the whole unit in unit test. And that unit could be part of your presenter, part of your view model. But in general, don't test private methods. Test private methods interactions with other components. And to see if actually you have tested somehow private method, you could check code coverage for that stuff. For content resolver testing, should we mock or make fakes? And if we mocked, what framework should be used? Well, lately I used content resolver for something. I can't really remember, but I remember that I created the whole adapter for resolving that stuff, so I wasn't directly testing content resolver objects. Verify objects private method. Can this be done? I'm not sure if it can be done directly. I know that Mockito has some hacks built into, but I believe if you satisfy compiler, you could make that verification with reflection. If you are brave enough, no reflection, and or just want to have fun with hacking stuff on Android and JVM. Okay, no more questions. Thank you for hosting me, and see you on the other side of the stream. Bye.